Hello, science fans. Let's travel back to 1985. Scientists in Antarctica discovered a gigantic hole in our planet's ozone layer, bigger than North America. This hole let dangerous ultraviolet radiation pour down, threatening life on Earth. Fast forward to today, November 15th, 2025. The hole is shrinking. This isn't luck, it's the result of global action and science. In 1985, our natural sunscreen was nearly gone over Antarctica, and ozone levels had dropped by more than half. The world faced a future with more skin cancer, crop damage, and harm to ocean life. But now, thanks to international cooperation, the ozone layer is healing. The amount of ozone-destroying chemicals has dropped dramatically. This is one of humanity's greatest environmental successes. It proves that when we act together, we can solve even the toughest problems. How did we get here? The answer involves chemistry, international treaties, and a lot of teamwork. Over the next few scenes, we'll explore how we almost lost the ozone layer and how we saved it. Get ready for the story of how humanity saved the sky. So, what is the ozone layer? Picture Earth wrapped in a blanket of air, the atmosphere. High up in the stratosphere, there's a special gas, ozone, or O3. Unlike the oxygen we breathe, O2, ozone's extra atom makes it a powerful shield. It acts like sunglasses for the planet, blocking harmful ultraviolet UV light from the sun. UVB radiation, in particular, can cause sunburn, skin cancer, eye damage, and harm plants and ocean life. The ozone layer absorbs most of this dangerous UVB before it reaches us. It's not a thick wall. If you brought all the ozone down to Earth, it'd be just as thick as 2 pennies. Yet that thin layer protects every living thing. Without it, life as we know it couldn't exist. So, when scientists saw the ozone thinning in the 1980s, it was a global wake-up call. Our actions, even small ones, can have huge consequences for the planet. The ozone crisis forced us to rethink how we treat our atmosphere, and it set the stage for a worldwide response. In 1985, British scientists in Antarctica made a shocking discovery. Ozone levels had plummeted. At first, they thought their instruments were broken, but new equipment confirmed the truth. A massive loss of ozone every spring. NASA's satellites showed a vast, growing area of severe ozone depletion. This hole wasn't empty space, but dangerously low ozone concentrations, less than half the normal amount. The result, more harmful UVB radiation reaching the southern hemisphere, raising risks of skin cancer and damaging crops and marine life. The world suddenly faced a direct threat to life on Earth. What was causing this? Scientists raced to find answers. The discovery sparked one of the most intense global scientific investigations ever. Researchers worldwide joined forces to solve the mystery. The fate of our planet's shield was at stake. The culprit? Man-made chemicals called chlorofluorocarbons, or CFCs. CFCs were everywhere, in fridges, air conditioners, spray cans, and foam insulation. Stable and long-lasting, they drifted up to the stratosphere, where UV light broke them apart, releasing chlorine atoms. One chlorine atom could destroy up to 100,000 ozone molecules. But why Antarctica? The answer: super-cold polar vortex winds and unique clouds that set the stage for massive ozone destruction each spring. All winter, chlorine built up on icy clouds. When sunlight returned, it triggered a chemical chain reaction, rapidly destroying ozone. This is why the hole appears every Antarctic spring. The combination of CFCs, polar weather, and sunlight created a perfect storm. We had unknowingly set off a global crisis. The world needed a solution, fast, and that's where international action began. Faced with disaster, the world united. In 1987, nations signed the Montreal Protocol, pledging to phase out CFCs and other ozone-destroying chemicals. It became the first UN treaty ratified by every country on Earth. Developed nations acted quickly, and a fund helped developing countries switch to safer alternatives. Industries innovated, creating new ozone-friendly products. By 1996, major CFCs were banned in developed countries. The results? The ozone layer began to recover, and millions of cases of skin cancer and eye damage were prevented. The Montreal Protocol proved that global cooperation and science-based action can solve even the biggest threats. It became a blueprint for future environmental success. After the ban on CFCs, scientists watched the sky closely. Healing was slow. CFCs linger in the atmosphere for decades. The ozone hole kept growing for a while, but then the trend reversed. By the mid-2000s, the ozone layer stopped thinning and began to recover. Ozone-depleting substances peaked around 2000 and have declined ever since. The World Meteorological Organization reports that 99% of these chemicals are gone. The ozone layer over most of the world should return to 1980 levels by 2040. The Antarctic hole will take until about 2066. This recovery is a direct result of global cooperation. If we'd done nothing, 2/3 of the ozone layer would have vanished by 2065. Instead, we avoided catastrophe. The healing ozone layer is proof that international action works. There's still work to do, but we're on the right path. Our sky is healing, one molecule at a time. November 2025 brings great news. The Antarctic ozone hole is one of the smallest in decades. The overall trend is clear, the hole is shrinking, and ozone levels are rising. This is the direct result of the global CFC ban. Fewer chlorine and bromine atoms mean less ozone destruction each spring. The polar vortex and icy clouds still form, but there's less chlorine to trigger damage. Scientists are also watching how climate change might affect ozone recovery. A warming planet could speed up healing in some areas, but colder stratospheres over the poles might slow it down. The story isn't over, but the progress is real. Each year, a smaller ozone hole reminds us that our actions matter. Environmental repair is possible on a global scale. We just have to stay the course. Even with progress, risks remain. Each spring, the ozone hole still exposes parts of the southern hemisphere to high UV radiation. Places like Tasmania face extreme UV levels, so sun safety is still crucial. Skin cancer rates remain a concern due to past damage. We must stay vigilant, wear sunscreen, hats and sunglasses, and seek shade. New threats have emerged. HFCs used to replace CFCs don't harm ozone but are powerful greenhouse gases. The 2016 Kigali Amendment aims to phase down HFCs, showing ongoing global commitment. Scientists monitor for new chemicals and illegal emissions. Quick action stopped a recent spike in banned CFCs. Protecting our atmosphere requires constant vigilance and cooperation. We can't take our progress for granted. The ozone story is more than science. It's a message of hope. We faced a global crisis, acted together, and are healing our sky. The Montreal Protocol is living proof that international cooperation works. We changed our behavior for the common good and made a real difference. This comeback story shows we can tackle other big challenges like climate change. The roadmap: listen to science, act decisively, cooperate globally, and innovate. Your choices matter. What you buy, who you support, and the awareness you spread. Let's stay informed and engaged and protect our fragile planet. The healing ozone layer is a symbol of our potential. When we work together, we can mend our world. Let's look up with